Hey guys, so today we're going to be looking at standard deviation, which is next on the series for machine learning by W3 schools. And today we're going to be basically looking at what standard deviation is and how to calculate it. So here we go. Okay, so today we're going to be looking at standard deviation, which is, again, like we're following the W3 schools series kind of on machine learning. So standard deviation is basically like a number that describes how spread out the values are. So that means that like a low standard deviation, that means that all of like the values are close to the average or like the mean of the total sum. So here, if we look at the first example, then you can see that this has quite a low variation. You can see that all of them are quite close to the average of all of these numbers. So this means that it has a low standard deviation. And a high standard deviation means the opposite, that the values are spread over a much wider range. So here we have, for example, a slightly higher standard deviation, which means that these numbers, like all of them, aren't so close to the mean of this set of numbers. So here we have an example, which is basically like the speed of a few cars. And for that, we're importing NumPy, and then we're basically like getting the standard deviation of these speeds. So run it, then you can see it's basically like 0.9, meaning that most of the values are approximately like in the range of 0.9 from the mean value. So the mean of all of these numbers is 86.4, and most of these values are like approximately 0.9 units from this main value. So, for example, if you take like 86 and then the average is 86.4, so that means there's like a 0.4 difference. Or if we look at 87, then there's a 0.6 difference. So that's basically what it means. So that means it's a low deviation, low standard deviation. Oh, sorry about that. And if we look at the next example, then for that here we have a slightly higher standard deviation. So what we get here is 37.84. So this one is much higher, given that we have 0.9 in the previous example. So most of the values are within the range of 37.85 approximately from the mean value, which is 77.4. So all of these numbers have the mean value of 77.4. And if you look at it, then approximately all of them are at 37.9 or like 37.85 units away from the number, which is 77.4. So that means that it has a higher standard deviation, meaning that it's spread out over a wider range. So this is basically like the NumPy method to calculate the standard deviation. And so as you can see here, that this is like, it's computing the standard deviation along the specified axis and returns the standard deviation, which is a measure of the spread of a distribution of the array of elements. So the standard deviation is, so that basically means that it's like, this is how it calculates standard deviation. So it returns like how much how much the difference between the mean of all the numbers in the array and the actual numbers is. That's basically standard deviation. So it's like an approximate. So the higher the number is, the higher the standard deviation is, and the lower it is, the closer together the numbers are, or like the lower the standard deviation is.